Hello everyone, welcome back. Hope you all are doing well. So, today we are going to learn about some topics which are very important to operating system, and without these the operating system cannot perform to its full extent. First, page replacement algorithms, then thrashing and locality of reference. Remember this. Now, as we I gave example without before starting any lecture. So, have you ever noticed how your computer becomes super slow when too many apps are running? Maybe you have opened a game, a browser with 20 tabs, and a video editor all at the same time. Yes, this is me, and I do it all the time. But how? Why does it happen? It's because of your computer, how your computer manages the memory, right? So, now, without wasting any more of your time, let us dive in. First, page replacement algorithms. But what is page replacement? Firstly, we should know that. So, when RAM is full, the operating system removes some pages to make space for new ones. As the name suggests, page is replaced. This decision is made using page replacement algorithms. Now, let us go to your home. If your fridge is full and you just bought fresh groceries, you need to decide which old food will go out and you have to make space for your new ones. Okay, then what are the types of replacement algorithms? First, we have the first in, first out. Just a second, everyone. It removes the first in first out removes the oldest page first, like a queue at the supermarket checkout. First customer in, first customer out. Because if a customer has arrived first at the cashier, then he will obviously go out firstly. Then what are the problems that may arrive will first in first out? So firstly, the first and major problem is that it may remove frequently used pages to reduce efficiency, right? Then we have the optimal page replacement. It removes the page that will not be needed for the longest time in the future. But if a need comes, it will swap again, right? Then now an example of this, like if you know you won't need milk for a week but needs eggs tomorrow, you throw away the milk from the fridge. Another problem of this is it requires future knowledge, which means that you should have the knowledge of the future, which is not possible. So it is not practical in real world computing, and it is not very often used. Then we have the LRU, or least recently used. As the name suggests, it removes the page that had not been used for the longest time, right? That has not been used for the longest time. An example of this, like a bookshelf, where books that haven't been read in a long time are moved to storage. It is better than first in first out, but requires extra tracking to monitor paper uses, so it may consume some extra memory also. But it is better than FIFO, which is first in first out. Then LFU. What is this? Least frequently used. It removes the least used page based on frequency of access. An example is this, like a restaurant menu where unpopular dishes are removed entirely. A problem of this is like the some pages might be used heavily in burst and then not needed, but LFU doesn't account for that because it will remove the least frequently used whether it is important or not. And the modern OS operating systems like Windows and Linux also, it uses variations of LRU and optimal algorithm to balance the memory efficiency between them and combining the advantage of both. So, moving further, what is thrashing? Right? What is thrashing? So, thrashing is when the system spends more time swapping pages in and out and then actually executing the process. It enters a state called thrashing. Now, imagine a chef in a kitchen with only one counter. if they have to keep moving the ingredients in and out of the storage consistently, then instead of cooking, it will just go to fetch the ingredients, it will slow them down. So thrashing also happens when too many processes are competing for too little memory. Instead of running efficiently, the system keeps swapping pages. Swap in, swap out, swap in, swap out, swap in, swap out. So it slows everything down. Now, how to detect thrashing? We learned about the factors in the previous lecture. So what were those? First, high page fault rate. Now, high page fault rate. The system is constantly fetching the pages. Then we have the low CPU utilization. The CPU is mostly idle because it's waiting for memory swap. Then the programs can be extremely slow. Even the simple task will take longer than usual. Like just opening your browser, it will take a longer time. So how to prevent all this? How to prevent the thrashing? First, increase the RAM. More memory means fewer page swaps, or use better page replacement algorithms based on your work or anything, for to reduce the unnecessary swap. Or we can also use a working set model. What working set model? What it does is that the OS will keep track of how each memory process actually need and limits the extra processes. Then at last we have the reducing the number of the running process, because if there are less programs running, then there is less memory competition. It's obvious choice, but it is not very much used in today's world because we need multitasking. That is why we are doing the page replacement algorithms and all the algorithms that we are learning. So if you have ever opened too many browser tabs and your system becomes unresponsive from next time, yes, that's thrashing and you should remember that. Moving further, let us look what is locality of reference and why I wanted you to learn this. So how does the let me give me an answer. How does the OS optimize the memory access? Any guesses? Okay, so that is locality of reference. Think of a student organizing books on their desk for easy access. Instead of running back to the library repeatedly, he have the all the books that he need at the desk itself. That is locality of reference. The program do not access the memory randomly. Instead, they reuse the same memory locations frequently. This behavior is called the locality of reference. We have two things in this. Firstly, it's temporal locality. What it means that if a memory location is accessed once, it will likely be accessed again soon. Then we have spatial locality. It means that if a memory location is accessed, nearby locations will likely be accessed too. For example, if you are studying for an exam, you keep important books on your desk rather than going to the library, like I mentioned before. So, how does locality of reference helps in memory management actually? First one is caching. Caching means that the frequently used data is stored in faster memory or cache for quick access. Whenever you open a browser or a site, a notification pops up to accept the cache. Yes, that is caching. Then we have efficient paging methods. The OS keeps frequently used pages in RAM to reduce the page faults. We can also improve the performance. The program will run faster because memory access is optimized. Whenever you watch a video on YouTube, or the app preloads nearby frames so that playback is smooth without buffering. This is spatial locality in action. Remember this from the next time. Now, comparing all the page replacement algorithms and their effects, firstly coming on to the simplicity. we can see that the first in first out is most simple because the first in first out. But the optimal algorithm is very hard to implement, while the least recently used and the least frequently used are in moderate. And coming on to the performance, we can see the optimal replacement algorithm is one of the best algorithm because it optimizes the page which needs actual replacement. And if we look at which replacement algorithm can prevent thrashing more and better, we can use the optimal replacement algorithm or the least recently used algorithm also. So to conclude, what we learned today, firstly, we learned about the page replacement algorithms like FIFO, Optimal, LRU, and LFU. Then we learned about thrashing, where excessive page swapping slows down the entire system, and also locality of reference, how memory access the patterns improve performance. So, understanding these concepts help us optimize the system pattern and improve the performance. So, uh, if you found this video helpful, don't forget to like, share, and subscribe for more tech explorations. See you in the next one. Thank you.